Here are the solutions to the activity for section 2.4. We learned two new facts in the introduction, the derivative of sine and cosine. And we're going to put those along with the quotient rule and the product rule and our other derivative rules into play here to solve some problems. So the first is just find the following trigonometric derivatives. These are all trig functions that we've seen before. And now just knowing the derivatives of sine and cosine will allow us to find the derivatives of all of these trig functions using the quotient rule. So we can start by, before taking any derivatives in part A, we can rewrite tangent as sine of x divided by cosine of x. And then right here we use the quotient rule to take the derivative. We get the denominator, which is cosine, times the derivative of the numerator, the derivative of sine is cosine, minus the numerator, which is sine, times the derivative of the denominator, which we learned was negative sine. And that simplifies to cosine squared plus sine squared all over cosine squared. Okay, and now here at this step we've taken the derivative, right? We're done. Technically that's the derivative of tangent, but we can write it a little bit neater and then we can rewrite it in a way that is commonly written. So cosine squared plus sine squared in the numerator, cosine squared plus sine squared is just 1. The denominator is cosine squared. I can rewrite that ratio as 1 over cosine quantity squared. And 1 over cosine right here is just secant. And so I get secant of x squared. So this is how we commonly write the derivative of tangent. It is secant squared of x. That's a fact that you will need to know. All of these facts are facts that you will need to know as we move forward. So we just saw that the derivative of tangent of x is secant squared of x. Okay, we can do something similar for the derivative of secant. We can rewrite it as 1 over cosine before we take the derivative. And then at this equal sign again, we are using the quotient rule right here. It's the denominator cosine of x times the derivative of 1, which is 0, minus 1 times the derivative of cosine, which is negative sine, over cosine of x quantity squared. And that simplifies right down here to sine of x over cosine of x squared. Again, that is the derivative of secant, but that's not how it's most commonly represented. So if you stopped there, that's great. You've done everything right. From here is the arithmetic or algebra to get to how we most commonly represent this derivative. So I'm going to rewrite that as 1 over cosine times sine over cosine. Those things are equivalent. 1 over cosine is secant of x, sine over cosine is tangent of x, and so we normally represent the derivative of secant x as secant x times tangent x. Okay, we do something very similar with cotangent. Rewrite it as cosine divided by sine. Apply the quotient rule, reorganize the terms ever so slightly, and we get to the derivative of cotangent is negative cosecant squared. Similarly with cosecant, start by writing it as 1 over sine, apply the quotient rule. Right here, we've taken the derivative. We could write the derivative of cosecant of x is equal to negative cosine x over sine squared. That's just not how it's most commonly represented. So we rearrange some terms and we get that the derivative of cosecant is negative cosecant x times cotangent of x. Okay, so those 4 trig derivatives are going to play a role the rest of the way. Most commonly, you'll have to recall the derivatives for sine, cosine, tangent, and secant, but the derivatives for cotangent and cosecant will come into play every once in a while. Okay, now find the equation of the tangent line to sine x plus cosine x times secant x at x equals pi. All right, so to find the equation of a tangent line, we need a point and a slope. We know to get that slope, we need to take the derivative. So here's the derivative using the product rule. So for the product rule, I'm thinking about this as the first function, sine plus cosine, and I'm thinking of secant as the second function for the product rule. So I get sine of x plus cosine of x, that's the first function, times the derivative of the second, which is secant x tangent x, plus the derivative of the first function. Well, the derivative of sine is cosine, the derivative of cosine is negative sine, times secant x. So there's the derivative using the product rule. Now the point is going to be the point when x is equal to pi. So when x is equal to pi, I get sine of pi plus cosine of pi times secant of pi. when that simplifies to 1. So our point here is the point pi comma 1. Now the slope, we need to evaluate the derivative dy dx at x equals pi. So everywhere I see a x up here, I'm going to replace it with a pi. I get sine of pi plus cosine pi times secant pi times tangent pi plus cosine pi minus sine of pi times secant pi. That all simplifies to 1 also. And so we have a slope of 1, we have a point of pi comma 1, and our tangent line then is y minus 1 is equal to the slope 1 times x minus pi. Okay, finally, here's a function that's a quotient, sine divided by 1 plus cosine. The first question asks us, where is f prime of x defined? Okay, well, we can find f prime using the quotient rule. We take 1 plus cosine times the derivative of sine, that's cosine, minus the numerator, which is sine of x, times the derivative of the denominator. So here, this minus sine of x is the derivative of 1 plus the derivative of cosine of x, because the derivative of 1 is 0. We do some rearranging of terms and simplifying these two terms right here. Cosine plus sine added together are 1. And this simplifies to 1 minus cosine divided by 1 plus cosine quantity squared. And so the question is, where is this defined? Well, it seems it would be defined everywhere unless there's a 0 in the denominator. And so the question then becomes, when is cosine of x plus 1 equal to 0? Or another way of saying that is, when is cosine of x equal to negative 1? So let's see, cosine is negative 1 for the first time at pi. And then if we go around the unit circle all the way till we get back there, that would be 2 pi units around. That would get us to 3 pi. And it would happen again at 5 pi, 7 pi, etc. Turns out we could go backwards to negative pi, negative 3 pi. So f prime of x then is defined for all x except x equal to, let's see, we'll put a dot, dot, dot here, negative 5 pi, negative 3 pi, negative pi, pi, 3 pi, 5 pi, etc. If you wanted to write that as all the odd multiples of pi or something like that, there's other ways you could write it, but that is where f prime is defined, everywhere except at those odd multiples of pi. Okay, so now we want to find the equation of the tangent line at pi over 3. So I've drawn this little piece of the unit circle here for you. There's pi over 3 radians, and that's the point 1/2 comma square root of 3 over 2. So that tells us that, just from that, we can read that cosine of pi over 3 is equal to 1/2, and sine of pi over 3 is equal to square root of 3 over 2. And again, to find the equation of this tangent line, we need a point and the slope. The slope is going to come from the derivative. The point is going to come from the original function. So the point has x value pi over 3, and whatever the output of our original function is at pi over 3. So we need to find that. So f of pi over 3. Let's go back and make sure we get it right. Sine over 1 plus cosine. So it's sine of pi over 3 divided by 1 plus cosine of pi over 3. Now we use those values we just decided. Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1/2. So let's see, we can simplify this a little bit. That's square root of 3 over 2 over 3/2, which simplifies to root 3 over 3. So there's our point. It's pi over 3 is the x coordinate of our point, and the y coordinate of our point is root 3 over 3. Okay, now we also need to get our hands on, let's change colors here, on the slope of the tangent line. The slope then is f prime at pi over 3. And f prime of pi over 3 is, let's see, let's go back up. We have the derivative. It's 1 minus cosine of pi over 3 divided by 1 plus cosine of pi over 3 squared. So cosine of pi over 3 we decided was 1/2. So that's 1 minus 1/2 divided by 1 plus 1/2 squared. So what's that? 1/2 divided by 3/2 squared. 3/2 squared is 9 over 4. And let's see, we multiply by 4 over 9, so we get 4 over 18 or 2 over 9. So that simplifies to 2/9. And so there is the slope of our tangent line is 2/9. And so we can put the point and the slope together, and the tangent line looks like y minus the y coordinate of the point, which we decided was root 3 over 3, equals the slope, which we just decided was 2/9, times x minus the x coordinate of the point, which is pi over 3. All right, there are the solutions to section 2.5.